Okay, gang, let's try number 35. So it's really important when you start these type of problems, when you're looking for the relative max and min, is to check the domain. Because aside from critical numbers going on the number line, so do domain restrictions. So the very first thing that I notice when I look at this is that it's a cube root. And cube roots, the domain of a cube root is all real numbers. Okay, so I'm not going to have any domain restrictions on this. Okay, so the next thing I want to find are the critical numbers. So the critical numbers come off the first derivative. So I'm going to go ahead and find that. I'm using the chain rule. I'm first taking the derivative of the 2/3. 2/3 minus 1 is negative 1/3. Sure, the inside's 1. Okay, so that's the derivative. I'm now going to see if the derivative is either equal to 0. If you have a fraction, how you set it equal to 0 is the numerator equals to 0. How you decide if it's undefined is the denominator equals to 0. Now, just to be clear, the critical number occurs in both of those cases, when the fraction is equal to 0 and when the fraction is undefined. Okay, so the fraction will be undefined when x is equal to -2, because then you'll be dividing by 0. So that classifies as a critical number. Sometimes people forget that the critical number occurs when the derivative is equal to 0, as well as when the derivative is undefined. You have to make sure you solve for both of those cases, not just the first one. Okay, great. So now what I'm going to do is I'm going to test the derivative. Okay, so this is the derivative. I'm putting up my critical number of -2, and I'm going to plug in because I want to see where the function is increasing or decreasing. All right, so I'm going to pick something to the left of -2, so something maybe like negative, I don't know, negative. Did I lose something here? Hold on a second, let me make sure. Cube root, you have to put the cube root in there. Sorry, gang, I have to put the cube root in there because square root has different rules than a cube root. Alright, so sorry about that. Always give me a minute or two to catch myself if I make a faux pas. Yeah, this has to be a cube root, so you got to put the 3 in there. Okay, so let's say I put in -10, for instance. Okay? So if I put -10 into here, -10 plus 2 is -8. The cube root of -8 is -2. -2 times 3. Well, in short, it's just gonna, the 2 and the -2 would cancel. We just say that's -1/3. So my point is, and maybe I should write it out because some of you are very visual. If I put -10 in here, you just want to know whether this is positive or negative. So if I put a -10 in there, this is going to be -8, which means it's going to come out, it's going to simplify. The radical part will simplify as a -2. I like to just reduce the 2's. It's a -1/3. So it doesn't matter that it's a 1/3. What matters is that it's negative, which means that this section, what one point does in this segment, all the points will have the same positive or negative output. So that means that everything here is negative, which means that the function is coming down in this segment. All right, now I'm going to pick something to the right of -2, like 0 is always a great choice. You sort of need your calculator to do this exactly. So maybe -1 would have been easier. All right, let me pick -1, just because 0 works, but some people might want like a value. I could use my calculator, but I don't feel like it. So I'll just pick something that's easy to calculate. All right, the cube root of 1 is 1, so it's 1, so it's positive 2/3. And again, it doesn't matter that it's 2/3. What matters is that you're finding out that this section where -1 would live is positive, which means that everything is positive over here to the right of -2. All right, so now you want to start writing down what your results are. Okay, let me just see if I can do that a little bit better. All right. Okay, so that means that the first derivative is telling you behavior about the function. So that means that f of x is increasing on the domain of -2 to infinity, and f of x is decreasing on the part of the domain that's -infinity to -2. You always keep these open. You never put like a bracket because at the end value it's just transitioning. Okay, it's not like an exact. You're just saying from this to this. Okay. All right. So that's. Let's see. Part A, find the critical numbers. We did that. That was part A. We did that. Find the critical numbers. Part B, find the open intervals, which function is increasing or decreasing. Okay, I just did that now. That was part B. And apply the first derivative test. And you don't have to do the graphing utility part. Okay, so part C here you have to do, which is the first derivative test. So how you do the first derivative test is you analyze what you have from the behavior of the derivative. So I see that this goes down. We hit a critical number, and then we go up. So this means that this is a relative minimum. It's a relative minimum because it goes down and then up. Okay, so we have a relative minimum. It's always relative on an open interval. This function isn't cut on either side. We have a relative minimum at -2. Now this is where people get confused because we want to know the relative minimum on the graph. And people will sometimes plug into the derivative. If you plug into the derivative, you're finding the slope at -2. If you plug this into the derivative, you're finding the slope, which is undefined. Okay, and we can sort of see that. What you want to do is find the coordinate. You want to find the coordinate. By the way, just in case anybody's interested, when you get an undefined, most of the time that means at that, graphically, it's making like a point versus like a parabolic looking shape. Just if you're interested, we'll get to that down the road. All right, so you want to find the y value or the height. So to find the height, you actually have to plug back into the original function. Okay, the original function, like what you started with. All right, so I'm going to plug that in. So I'm going to do f of -2. So -2 plus 2 to the 2/3, which is 0 to the 2/3, which is 0, right? Because you're taking the cube root, of 0 and then squaring it. The cube root of 0 is 0, 0 squared is 0. It's okay that it's 0. It just means that the minimum, what that means is here at -2, what it means is that -2, you can see the graph comes down, it hits the minimum, and then it goes back up. I'm just rough sketching this. It's actually quite a lot. It's a way more flatter than what I just drew, but I just want to give you a sense of what you just found. Okay, so it's okay. You can have a height of 2. The minimum here, the relative minimum is happening at -2, 0 on the graph. So just make sure at the very end you plug into then the original, not the derivative. At the very end you plug into the original to find the y value. It's only when you're doing the number line that you plug into the derivative. Okay, so this can get very confusing. Sometimes you're plugging into the derivative, sometimes you're plugging into the original function, and you've got to really keep it clear when you're doing what, why you're doing that, okay? So the derivative tells you where the function is going up and down. The original function is going to give you, if you put in an x value, it's going to give you the height, which will be the y. All right, gang, that's it on this one. We're eventually going to be graphing these, so you want to get this part down because this is just like a subset to like doing a larger question. Okay, gang, I'll catch you on another one. Bye-bye.